Hi guys, we're going to talk about air release and vacuum breakers when it comes to drip irrigation. Air is going to be a critical thing to manage, and so we've got two different styles of air release vacuum breakers. They both do the same thing on this one, but one of the things, as you saw, when we pressurize this drip system, there's going to be a significant amount of air from drain out and bleed out of the lines. There's going to be air left in here, and I need a way to get that out, and I don't want to put that out through the drip emitters. I want to control that through my air release valves. And so when we engage the pump, you're going to see a slug of air and water pop out here as it gets the air out of the way, so that we're moving water more efficiently without that compressed air bubble in place, and doesn't ask the emitters to move that air. Now, one of the key reason, and really the main reason in my mind, that we need air management on these systems is because when the pump turns off, the emitters are going to continue to ooze water. Really, we're going to lose our pressure compensation then. At lower pressures, the lower lines are going to ooze more than the upper, which is going to leave the upper lines, if we don't have another place to get air in, it'll leave those upper emitters to be a vacuum point that air or pressure gets equalized. And if we're sucking back in out of the emitters that we've just sent wastewater out in that silt and clay filled environment, we're going to plug up our lines. And so one of the primary things I need is air release on the return side high enough to get air back into this system at the end of each dose. So I've got to make sure that the return manifold is higher or as high as the line it's serving. And so I want to make sure I don't have a P-trap of water in between the drip line and the return manifold to make sure we can get that air out, but more importantly, air back in after the dose is over.